we go. First thing we notice is we have parentheses, so that usually is going to indicate a u substitution for us. So we'll pick u as 1 minus x, the quantity in parentheses. Our du, be careful here, the constant goes to 0, the negative x would go to negative 1 dx. So this becomes our little guide for converting this integral in terms of u. So our first step is that we want to switch this all to u. And so I always start with the most obvious thing. I say, okay, this u is 1 minus x. So all of this is going to become u, and then it's raised to the 99th power. And I do this kind of in little steps just because I think it's easier for us. Okay? All right, so if you look at what's left over, you have this x and you have this dx, and you somehow have to get rid of that x variable and the dx variable. So let's start with our du. Okay, so the du is defined as negative dx. So to get du, I will need to multiply in by a negative 1. And of course, if I multiply in by a negative 1, I've got to balance that out by multiplying or dividing by a negative. So that overall, what we have is a negative times a negative, so we get a positive, our original integral. Now, what that buys for us is that now this negative dx, that we can say is equal to our du. We still have the u to the 99th from our conversion, but unfortunately, we still have the x. So this is what we're looking at. We're looking at the integral negative, the integral of x u to the 99th du. So the question is, how do we get rid of this x? Because everything has to be in terms of u. So to do that, we go back to our little key of life here, that u is equal to 1 minus x. And the great thing about this is that you can manipulate this little equation as much as you want to try to get your integral in terms of u. So in this case, I want to figure out what x is equal to. So I am going to manipulate this to solve for x. And that's because I'm trying to replace x with something in terms of u. So if I do that, one way of doing this would be to subtract 1 from both sides. Get u minus 1 is equal to negative x, and then divide by negative 1, divide by negative, divide by negative. So you get negative u plus 1 is equal to positive x. And that is a perfectly acceptable answer, a perfectly acceptable equation, because it came from our definition of u. So what we're going to do is we are going to replace this definition of x, this x, with negative u plus 1. And because it is two terms, we will put parentheses around it. We still have the u to the 99th, we still have the du, and then the negative. Now, at this point, you're looking at it and it's like, okay, how am I going to integrate this? I also have parentheses, so I have to use u substitution. You do not want to go down that road. You want to simplify as much as you possibly can. And if you get a little creative about your simplification, you will see that this u to the 99th can be distributed, just like we would do with derivatives, and you will get negative integral negative u to the 100th, again adding exponents there, plus 1 times u to the 99th, u to the 99th, and then our du. Okay. So now what we can do is we have simplified, we have two terms, so we can integrate each of these individual terms. Now, I would personally be very, very, very careful with this negative sign. You have two terms, so that negative sign is going to get distributed to all of the integrals. So we need to be super careful about that, okay? So we have a negative u, we add 1 to the exponent, divide by the new exponent. Over here, add 1 to the exponent, divide by the new exponent. Then, because we don't have bounds, we will add the plus c. But again, all of this is getting multiplied by a negative outside of that integral. So this is important because in our simplification of this, it's not going to be a positive here or a positive here and a positive here. What happens is this negative gets distributed to this term, but it also gets distributed to the second term. We are not going to distribute it to the plus c because the plus c is an arbitrary constant. And so because it's arbitrary, it's just plus c. It doesn't matter if it's negative c or plus c. Okay, so here's what it's going to look like in our final integration step. We are going to have this negative times negative, u to the 101 over 101. Then this negative times positive is going to give us a negative u to the 100 over 100 plus c. Now, of course, that is not our final answer because we have to switch back. So we switched to u, we integrated, and now we switch back using the fact that u is 1 minus x. So this u is going to get replaced with 1 minus x. This u gets replaced with 1 minus x. So we have 1 minus x to the 101, again making that replacement, over 101 minus u gets replaced as 1 minus x to the 100 over 100 plus c. And that is our final